In this example, we're asked to find the radius, tangent, point of curvature, point of tangency, length of curve, long chord, external distance, middle ordinate, and the deflection angles for all whole and half stations for a simple curve. Basically, we're asked to find everything. We're told that this curve has a point of intersection, a PI, of 263 plus 56.04, a degree of curve of 6 degrees, and an intersecting angle of 27 degrees. So the first thing is to draw a picture. We were given that in the problem, but make sure we have some picture representing what our given or known information is. So this simple drawing would present the given information. Next, we need to calculate the radius. This is always going to be an important component in the calculation of horizontal curve components. We know the degree of curvature, so we need to use the equation to convert radius degree of curve to the radius. So the radius equals 18,000 over pi times 6 degrees. Gives us a radius of 954.92 feet. If we know the radius, we can calculate the tangent length, t, where the tangent length t equals the radius times the tangent of delta divided by 2. So 954.92 multiplied by the tangent of 27 divided by 2 gives us a tangent length of 229.26 feet. Now with the PI that was given and the tangent that we calculated, we can find the station of the PC. PC equals the PI minus T. So station of the PI, 263 plus 56.04, or just in feet, that'd be 26,356.04 feet, minus the tangent length, 229.26 feet, gives us a PC station of 261 plus 26.78. Now we need to calculate the length of curve to find the PT, where L, the length, equals 100 multiplied by delta divided by the degree of curvature. This will equal 100 times 27 divided by 6, gives us a length of 450 feet. With this, we can find the station of the PT, where the PT equals the PC plus L. So we're going to add the station of the PC, just in feet, is 26,126.78, plus the length, 450 feet, gives us a PT station of 265 plus 76.78 feet. Now we can calculate the long chord. The long chord is 2 multiplied by the radius multiplied by sine of delta divided by 2. So 2 times 954.92 multiplied by the sine of 27 divided by 2 gives us a long chord of 445.84 feet. Now we can calculate the external distance. External distance E is the tangent times tangent of delta divided by 4. That equals 229.26 multiplied by the tangent of 27 divided by 4. Gives us an external distance of 27.13 feet. We can also calculate the middle ordinate M, where the middle ordinate is the radius multiplied by 1 minus cosine of delta divided by 2. So this is 954.92 feet multiplied by 1 minus the cosine of 27 divided by 2. Gives us a middle ordinate distance of 26.38 feet. Now we need to set up a table to calculate our deflection angles. We were asked for every whole and half station between the PC and the PT. So we start with the PC and then label every 50 and whole station until we reach the PT. Next, we want to find the incremental lengths, the lowercase l. So from the PC to our first half station is 23.21 feet. The distance in the remaining points of interest are 50 feet until we reach our PT, and then the incremental distance there will be 26.79 feet. The incremental deflection angles equals lowercase l that we just computed multiplied by our degree of curve divided by 200. And so all the intermediate steps will be 1 degree 30 minutes, where the first and last will be different. The first one is 0 degrees, 41 minutes, 47 seconds. And then our last angle is 0 degrees, 48 minutes, and 13 seconds. Next, we can calculate the cumulative deflection by adding up those incremental deflections. So we should start with our first incremental deflection, 0 degrees, 41 minutes, 47 seconds. And then the next series, we're just going to add the 1 degree, 30 minutes, 0 seconds. At the end, again, adding the 0 degrees, 48 minutes, and 13 seconds. As we add these up cumulatively, we find that the total 13 degrees, 30 minutes is half of the intersecting or deflection angle, which checks out. That's our check for deflection.